the Post argues that a memory system is not just a capability layer, it is a massive liability surface.
When you give an agent a durable memory store like a vector database or large knowledge base can query, you are fundamentally giving attackers a persistent long-term vector to influence the agent. If an attacker can inject malicious information into that database, it lies dormant until the agent searches for a related topic. If an agent autonomously writes to its own durable store, say, logging user interactions, an attacker can feed it a malicious interaction.
And the agent just logs it away.
Exactly. The agent logs it. Weeks later, the agent retrieves that log to influence a future action, and the payload activates. The store itself is the attack vector.
If I have a vector database with a million company documents and an attacker sneaks in one or two poison files, won't the AI just look at the overwhelming majority of good data and ignore the bad stuff?
It demonstrates with mathematical clarity how a shockingly small number of malicious documents, sometimes just a fraction of a percent of the total database, can entirely bias the agent's retrieval and dictate its downstream behavior. An attacker crafts the poison document to have an embedding a mathematical representation that is perfectly optimized to be closer to specific target queries than the actual ground truth documents.
Okay, I see.
When the agent searches for context, the poison file acts like a magnet, pulling itself to the top of the retrieval results. The agent pulls that corrupted file, assumes it is the authoritative ground truth because it was the top result from its own database, and acts on it.
So they just need to slip a highly optimized, corrupted file into your knowledge base.
You absolutely cannot assume retrieval corpora are trustworthy simply because they are large. Size does not equal security in vector space.